welcome to thedeciphers.org. My name is Cordelia Kataria, and I am a 9-year-old computing explorer and problem solver. So right now I'm with Reshik, and we're going to solve a British Informatics Olympiad problem, and specifically BIO round 2, and it's question 1, and it's called revision. And we're going to do a session on about it and hopefully even get to code out a solution. So the question says, one second, So it says, in order to encourage walking in the countryside within which is nestled that knot of villages known as the Indians, fixed telescopes have been mounted along a path. There walkers can gaze upon bright gardens, ancient forests and romantic chasms. There walkers can pause and take stock of the world. There walkers can curse the telescope as they take their money and refuse to work. Along the path, and telescopes have been placed, and the satisfaction a walker receives each time they use the eye telescope is SFI. After visiting a telescope, a walker can travel to an adjacent telescope, I+1 or I-1, except at the extremes of the path where there is only one adjacent telescope. Walkers are obliged by local ordinance to use a telescope each time it's reached. All walkers begin at the first telescope, and walkers are only permitted to use a telescope once before they move to another telescope. The J of walker on the path uses telescopes on U of J occasions and wants to maximize the sum of their satisfactions from using telescopes on their walk. For example, suppose the satisfaction values in order are 1, 2, 3, -1, -1, 10. If a walker visits 5 telescopes, their maximum satisfaction is 11, that's 1, 2, 3, 2, 3. And if a walker visits 6 telescopes, their maximum satisfaction is 14, 1, 2, 3, -1, -1, 10. The first line of input will consist of 2 integers, t, then w, indicating the number of telescopes and walkers. Each of the next t lines will consist of a single integer, s of I, and that indicates the satisfaction received from the IF telescope. Each of the next w lines consists of a single integer, u of I, indicating the number of occasions the J of walker will use a telescope. You should output a single integer, the sum of the walker's maximized satisfactions. I think we can use a recursion, and if it's I plus I+1, because there's 2 choices, I+1 or I-1. Yeah, so we can used recursion to just, to work out the maximum satisfaction, because with
So what will the recursion look like? What will be the variables that will track?
so the variables will be just 1 second, the eraser is just not working. Just ignore that. So maximum. So the different variables will be there will be it will pass the number of moves, and also we'll pass the number of moves. We'll pass the telescopes. That indicates the number of the satisfaction level of the telescope. It's UFI, and we'll also pass I think I will also pass the I, which is the index.
So what are you passing in the telescopes?
Yeah.
What are you exactly passing in the telescopes?
In the telescopes, I'm passing the satisfaction received by the telescope. So just U of J.
Do you need to pass it in a variable?
I think so. I mean, actually, I don't think we need to, because we can before
That variable never changes, right?
yeah, because at the start we can set telescopes to be the telescopes, and we can use and you can use it inside the function.
Okay. So moves comma I becomes a state.
So yeah, I is a state.
Great. Then what will our recursion look like?
We'll just see. Whoops, 1 second. Just not working. Right, there we go. So the recursion like just if I is len of telescopes, Actually, I'm not sure we need to pass moves either because it will also never change.
It will also.
Never change.
So what does the state exactly represent? What state of moves I mean?
Um, um,
It basically means that if we are at ith telescope in moves, let's call the state I comma j.
I was thinking of moves to just be the number of moves that we're doing. For example, 5 telescopes, then the move is 5, but I guess that way would be faster. It's kind of low level DP.
Okay. So you don't want to store moves either.
So we we could but if but we don't. We could, but it'll be faster if we keep it in there.
I didn't get you, but
So the code will be faster if we keep moves inside the function because then moves can be the moves that we've already done. And we actually I think we need one more variable because moves is the number of moves.
okay.
So comma and then actually done comma I ran. So if I is the if I is actually I mean if if len of I underscore done because that's the number of moves that we've already done. If len of that is moves, then we'll just return.
Are you writing on the base case right now?
Yeah.
Okay.
So if that
So what does I10 represent?
that's the number of indices that we've already done. For example, if we've gone to then 0, then 1, then 2, then 1, then 2, then it'll be 0, 1, 2, 1, 2. That's
It will store the path, is that right?
yeah.
Do we need to store the path?
I don't.
We just need to output a single integer, right? The sum of the max and satisfaction.
Yeah.
Okay, we can also store the news that is world.
So instead of I done, we'll just do move done. That'll store the number of moves left. That'll store the number of moves left. If move left is 0,
So what does move store then?
the moves is the total number of moves we can do. For example, if for the first thing, if it visits 5 telescopes, then move will be 5, and moves left is the number of moves left, so just moves minus how many moves already done.
Okay, so moves is a constant, right? It is not changing at all.
Yeah.
So it doesn't need to be part of the state. It's just like knowledge for us.
Yeah, I guess.
Okay.
So just take that out. Right, so then if moves left is 0, then just return 0. Whoops. Return 0. Okay, and that's the base case. So return max off. I guess the function is called etate. For off, whether that name off I plus 1. Easily off that, comma, all the exact same thing, I minus 1. Okay. And I think that's the function.
So do we need to add a value here?
Which value?
So it will get some satisfaction from this, like the current telescope as well, right?
Forgot about that. Return max off that. And then that plus, I'm just calling it tally for short. So tally off by So I think that's the function.
Okay, they need to be a few edge cases, right? Like with the end telescopes.
Oh yeah, so right in the bottom and then so if I is 0
Mm-hmm.
then return of 1 comma so return that off 1 comma move
Mm-hmm.
minus 1 if I is n minus 1, assuming that, and we'll also set n to be ln of telescopes minus ln of telescopes. So return of n minus 2 comma left minus 1, and we also add telly telly of 0. So telly of n minus 2.
N minus 1. Yeah, just N minus 1.
N minus 1.
Hmm. So what will be the complexity of this solution?
So I guess it'll so there's approximately 2 possible options for each state. So it's about 2 to the power of n. And n can go up to
So there are actually two variables in this state, right? One is the number of telescopes and one is the moves.
yeah, so we'll actually have to multiply, so it's actually we'll have to, so it's w times t to the power 2 to the power of t. That's 2 to the power of 20 times 2 to the power of 2 to the power of 20. That's the maximum we can get, and that's just gigantic.
Can you write that down somewhere?
That's order of w times 2 times 2 just times 2 to the power of number of telescopes. Let's order off. About 20 plus.
So the complexity is usually described in the variable itself. We're going to make that mathematical thing. So can we improve on this somehow?
I think we can. Probably. I think we can use. Brute force search for this, just like the problem we did before.
Okay. We can because we have already written a recursive solution that works. We can also use a DP here, right?
And should we cut out the solution that we already got? Should we cut out the recursive solution that we found?
Yeah, sure. Are you going to code it on editor?
Yeah, I'm going to code it on Spider. So maybe if you just watch the stream, then you'll see what I'm doing.
Yeah.
I'm not sure if you can. That didn't work. Okay, so I think what we can do is just name it define front and I comma move underscore move left. And we're also going to set telescopes to for example input was 1, 2, 3 -1 -1 10. And we're also going to set n to be none of these. So if moves I've got left is 0, then what we're going to do is just return 0. And if I is 0, then return then sunk off was I comma move left -1 and sunk off I +1.
We move to I plus 1, right?
Yeah. The stream is a bit behind, so you'll see what I've already written.
Yeah, there's some lag.
So plus telescopes off. I if I is n-1, then let's just do that exact same thing. So we can. I'm just double checking it. Let's find mine. Otherwise, we can just return max off. Let's fuck off my plus 1, comma, move left, minus 1. And comma, minus 1, comma, that plus telescopes of I. Print out blank off. So we'll do the first one, does 5, comma, moves left is 5. So if we want it, then
I should be 0.
Right, that's 11, which is the correct answer. And now, I should try, let's try 6. And it's 14, which is also correct. Seems like our code is working.
Now we need to store, like, there is a property that we can use DP here, right?
Which property?
So there are 2 properties, right, for DP.
Yeah. So should
We are already using the recursive function. It has.
Should I switch back to Microsoft OneNote?
So you can just convert this into a DP solution, right? That is pretty easy. You just need to write the DP tree, and this becomes infinitely faster.
Yeah. And also, you could measure the amount of time. Was delta time. Let's just use time. Simple delta time. Let's see. Delta time. And that helps us find the time of it. That was time delta.
We can also increase our moves left a little, so that way we get a better idea how fast our code is going.
One second. I'll just use time. So it's pretty fast, seems. So, also,
You can increase the number of moves so we know how slow it really is.
yeah, so if we increase it to 10, you can see that we only multiplied by 2 approximately, but but it got much slower, and that's still not the maximum. That's still not the, even though it's still not very slow, it's still a very big slowdown. And if we
Yeah,
increase it to
it's an order of 5 slow down, just more than order of 8
and
slow
if
down.
we increase it to 100, which I already did, then it's super slow.
Yeah, you can just stop the door and it won't even. Yeah.
So now let's switch that back to 5, maybe. Then we have to add a add something for the DP. But I'm not sure how to update the DP because wait, uh, just completely.
Make the DP global, first of all.
I'm not sure how to make it global when it's inside a function. Um,
Just declare it globally.
okay. 1 second, I can't find it. I'm not sure if that will work.
No, just make it global. Right? Where have you written n equals len of telescopes? Just write dp. Yeah, dp equals dictionary.
So I
So you don't need to write global. It's already in global scope.
So should I remove it from the function?
Yeah, you can.
Every do. So can first let's do variable max that that is 0. So max that basically stores the result.
You can use elif statements. But
dp of I think it's I.
so if the I is 0, you don't need to go to I minus 1 again and again. Like your line 10 and line 14 are repetitive. No? And also, if it goes on 0, it will just go beyond that by like 14.
Um, um, you mean 11 and 13?
Yeah, so in the conditions I meant, so if you run 0, it will go to -1 by a line 14. So just mirror that using elif statements, if elif and else.
Um, uh, how do we use, how should we do the, elif statement?
So if it's equal to 0, your only option is to go ahead, right? So if I is equal to 0, you go ahead. Else, if I is equal to the last element, then you want to go before. So just write elif instead of if. The second if.
And, else,
And else this. Max. Okay.
so it's 11, and I guess it is a tiny bit faster. Let's crank it up to 100, and
You also need to check if like DP exists or not.
oh yeah, so let's do it here. If I in DP, return DP on 5.
If I comma moves left, both are the part of the statement.
Um, um, and I forgot that we also need to put move left and left. Next, if I comma move left and DP then returns DP off. Let's not do 100 right now because we don't know.
Yeah.
That's 11. It seems to be working. Let's try 6. Okay, 14, and it's actually a bit faster than if we inserted 5. So that seems good. Let's try 100. And it's 437, and still super fast. But I'm not sure whether it would still be faster if it's 2 to the power of 20, because
So what will be the complexity here?
I'm pretty sure it's order of n.
Might want to check again. For DP, the time pressed is the number of states into the time required to calculate each state. So the number of states here are.
So the number of states are just 2 to the power of 20. That's
2 to the power 20 into 2 to the power 20 because I and J both can go up to 2 to the power 20.
Yeah. So yes, that's order of n's. So that's order of n squared.
Right.
So, I think there's probably a way to do it even faster because it's a 2 to the power of 20 is the maximum, so 2 to the power of 40 would take a long time.
So we need to come up with some observation, right?
Yeah.
So let me try giving you a hint. So can you come back to the whiteboard?
Okay, 1 second. There we go. Right. I'm pretty sure I already realized what it is.
Okay, go ahead.
So I'm pretty sure that both of the 1 second. My camera seems to have just gone a bit big. There we go. So I'm pretty sure the observation is that. So I realised that 1, 2, 3, 2, 3. That's just repeating between 2 and 3. So I'm pretty sure that the maximum would just be repeating between 2 states. And
Why will it repeat between two states and not, let's say, three?
Because if it's repeating between 3 states, then that's the same as repeating between 2 states, because if it was 1, 3, 4, 1, 3, 4, then 3, then that's the same as that's repeating from 1 to 3 and 3 to 4, and that's also repeating from 1 to 4. Because
if you have an option, we won't ever go back to 1, right? We'll just jump between 3 and 4. Does that make sense?
Yeah.
That's why there will only be two numbers. Finally, let's say you have an infinite number of moves. So unless you reach a certain point, let's say 3 and 4 in this case, you keep making a fusions to reach 3, 4, and you'll jump between them after that.
Yeah, because for every triplet, we can remove the smallest one, and then they'll make a higher thingy.
Right.
And we can't remove it when it's the pair because you can't visit the same telescope. You can't use the same telescope more than once. When it's
Exactly. You need to jump between two only.
Yeah. Which is exactly what a pair does. Just in the most optimal way.
Right.
So I'm not sure if it'll work, but I think we might need to find the prefix sum and suffix sum, and then
why do we need the suffix sum?
It's because for the second element in the pair. Yeah, but suffix sum is basically just, you can calculate that from prefix sum, so we only need the prefix sum. Maybe the minimum and maximum prefix sums. I think I'm not sure if
Minimum and maximum prefixes, no? Okay, so for every element here, let's say our array is like this, something like this. So for this given element, we first to see how much cost does it take to reach the ith index? How much cost?
I can't see the thingy.
You can't see what I'm writing.
Yeah.
I'll restart my download.
Yeah, I think I can see now, but I can't see the elements.
Yeah, I haven't written the elements. I'm just trying to make the logic up. So how much cost to reach I?
I think it's because it takes some time to process.
No, I haven't written any elements whatever.
Yeah, I know.
I'm just trying to make an algorithm right now.
I mean, I didn't see the list until a few seconds later.
Okay. Now can you see it?
Yeah.
Okay. So we just take how much cost does it take to reach I, and then we shuffle from I and I plus 1 between. So we come to 0 and then we shuffle between 0 and 1. We can do this for all indexes, right?
Yeah.
So for each move, we can just shuffle between these two. Does this kind of make sense?
Yeah. Actually, I think and it doesn't make sense, and also I think we might need to take the two maximum pieces and not the maximum min, because I thought of the maximum and the minimum because the second one was 1, 2, 3 minus 1 minus 1 10, but that's just repeating from 3 to 10, I guess.
No, it will repeat from between 10 and minus 1, no? It's more optimal to go between 10 and minus 1, 10 and minus 1 than to go back to 3 and then go to 10.
Okay, then. Yeah, because...
Let's say you have...
I'm pretty sure that we can work it out by, for example, the 3. We just need to take the sum of all elements from 3 to 10, not including 10, and divide it by the amount of moves, and then find the maximum of that to use as your starting element.
Can you explain it with an example?
So, for example, if we use 1, 2, 3, we use 2, 3 minus 1 minus 1 10. Then we have to find so we have to first somehow calculate the first element. Let's say the second one, which is probably going to be in a similar way to Wait, it's not. Just somehow calculate the next one and then just. Right, so let's see 3. So let's take the sum of all that we get 10, 9, 8, then 11. So the total sum is 11. So 11 divided by the length of that is 11 divided by 4. 3, it's 11 divided by 4. Then for this minus 1, it's 9 divided by 1, which is 9, and this one, it's 9 and 2. And the maximum of these will be this 9, which is...
Just the root 10 and 2. Yeah. 10 and 3 actually. And then 9 and 2.
And then,
Okay, so you have to consider 2 things, right? Once again, is what I'm writing visible? It's showing some issue with background.
So, where are you writing? On OneNote?
Right where you've written the array.
I can't. Oh yeah, I can see it now. Yeah. Just
Go a little towards right.
I can see it now.
Okay. So you need to consider 2 things, right? The sum is the first thing, and you also need to consider the number of moves it takes to reach that sum.
Yeah.
So
when
you go 3 places here, which takes a total of 3 moves, or you'll just jump between 10 and minus 1 3 times.
Yeah. You just do the 10 and minus 1. Because even though because it takes more moves to get from 10 to 3, and
It's not even worth it, right?
Yeah.
Can you say that generally, like, why is that true?
Because the sum divided by the number of moves is more for that minus 1 than it is for the 3.
Yeah.
That's what I've worked out.
Right. So based on this, we can come up with some kind of algorithm, right?
Yeah.
So if I write something like for every, let's see, so for each move. So basically it's just the thing that I've written here. We just need to check how much time does it take to reach ith index, and then we need to shuffle between I and I plus 1 for the number of moves that are left.
Yeah.
And we can do this for each index and it will give us the answer.
Yeah. But I'm pretty sure that'll be order of n time complexity, which is still too large because we need order of log n or less.
No, order of n works in.
But the maximum is 2 to the power of 20. That's a bit too big.
2 to the power 20 is around 10 to the power 6, something like that. Let me just put it on the calculator. Yeah, it is 10 to the power 6. 1, 2, 3, 4, 5, 6, 7. Approximately.
Yeah.
So order and solutions would work in.
Okay. I think it might have been something else I was thinking of.
Oh, what were you thinking of?
I'm not sure. It's just probably 2 to the power of. I think I thought it was 2 to the power of 2 to the power of. Wait, what was that? What was it? 36 was. And I forgot that 2 to the power of 20 was not really that big. So
Yeah, it's around 10 to the power 6.
Yeah.
Approximately.
That's why you always need to type out it in a calculator to see whether the solutions will work. Actually, you don't always need to, but for BIO problems, you might need to. So,
Can you say that again?
For BIO problems, you might need to work out what you might need to work out how much how much time and order of n solution would be, order of.
Yeah, it's important to think about the time complexity for every solution that you think of.
Yeah.
It's extremely important.
Yeah.
Okay, cool. So today we were at least were able to come up with one solution.
Yeah.
So
Actually, we were able to come up with 3, and one just might be the most optimal one.
right.
Unless there is another one that's more optimal that we shall have to figure out in the next class, I guess. It's 5:32.
Yeah, sure.
It's 5:32, so I think we should stop streaming.
Yep.
And thank you